Today we are going to discuss equivalent decimals. Equivalent decimals are decimals that name the same amount. The word equivalent is the same as equal, so these are literally equal decimals. Below I have three different decimal representations. The first figure we have here is divided into tenths, and we know this because if we count the columns, so we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We have 10 equivalent sections within this block. Of those 10 total sections, I have shaded in one region. So I have 1 out of 10 sections are highlighted. As we discussed in our last lesson, you do have a choice of writing this number as 0 and 1/10, or you may choose to write it as just 1/10, which would be a decimal point 1. Now on to the second figure. In our second figure, you see that we have a significant larger number of divisions. We still have our 10 columns, but in addition to our 10 columns, we have drawn 10 divisions horizontally. So now I have a 10 by 10 square, and we know that 10 times 10 is 100. So this figure, figure 2, is divided into 100 pieces. Of the 100 parts, we see that 1 has been shaded in. So this number would be 100th. We talked about in our last lesson that that can be written as 0 and 100th, where the 1 falls in the hundredths place. Or we can choose to leave that first 0 out and just say 100th. But you have to be very careful that whatever that digit is, the last digit needs to be in the hundredths place, which is the second place value to the right of the decimal point. For our third model, you'll see that again we are in divisions of 100, but I have shaded 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 of those boxes. So this figure would represent 10 hundredths. Notice my last digit of 10 falls in the hundredths place because my divisions are in hundredths. Now, in looking at all three of these figures, figure 1, 1/10, figure 2, 1/100th, and figure 3, 10 hundredths, two of these figures look fairly similar. The first and the last have the same amount shaded in, even though we have our first figure in tenths and our third figure in hundredths. So, despite the fact that we are discussing different place values, these are in fact equivalent decimals. 1/10 and 0 and 10 hundredths are equivalent decimals. Here we see that we have 1/10 is equal to 10 hundredths, and it looks very similar to 3/10 equal to 30 hundredths. Okay, let's look at another example. Here I have three figures again. My directions read, identify the equivalent decimals using the decimal models. So in looking at these three figures, you may immediately identify that this first figure has 3/10 highlighted. This second figure has 3/100ths shaded. And our final figure over here is also in hundredths, and it has 30 of those boxes highlighted. Now, while all three of these numbers do look similar, here we have a 3 and a 0 with a decimal point. Here we also are seeing the 0s, 3s, and decimal point, and just like the other two, here we have a 0, 3, we have another 0, but we have our decimal point. So these three numbers look similar, but the portion that is shaded in each of these holes does not look the same. If you'll look at this third figure and compare it to the first figure, you may see that they are actually equivalent. So despite the fact that these two numbers are different, they are actually going to be considered equivalent decimals. Now I want you to start looking for a pattern here. 3/10 is equal to 30 hundredths. If we look at our last slide, let us now identify the equivalent decimals from these three given models. The first model is in tenths, and of the tenths we have 1, 2, 3, 4, 5 of these tenths are shaded. So we would write that as 0 and 5/10, or you could write just 5/10. The second figure is divided into hundredths. We have 10 boxes this way by 10 this way. 10 times 10 is 100. So this figure is in hundredths. Of those hundredths, we have 10 boxes here, 10 here, another 10, 10, and 10. So we have 10, 20, 30, 40, 50 boxes out of 100 are shaded, and so we would express that number as 50 hundredths, or 0 and 50 hundredths. And finally, the third figure here is also in hundredths, and of those hundredths we have 1, 2, 3, 4, 5 groups of 10, so 10, 20, 30, 40, 50, plus we have an additional 1, 2, 3, 4, 5 boxes. So we would express that number as 55 hundredths. Okay, so let's compare. You'll notice that the first figure looks really very similar to both of these figures, but this figure has a little bit more. So despite the fact that these numbers do not look identical, they are considered equivalent. 5/10 and 50 hundredths are equivalent decimals. The only difference is you have an additional 0 at the end of the other number. Okay, looking at the models, first let's identify what the decimal equivalents are of each model. This first model here has divisions of 10, so we are in tenths. And of those 10 sections, 9 are shaded, so this is 9/10. For the second figure, you'll notice that this time we are in hundredths. We have 100 boxes here, so we should have our last digit in the hundredths place. Of those, we have 10, 20, 30, 40, 50, 60, 70, 80, 90 shaded boxes. So when I write this, it should be 90 hundredths with the last digit of 90 in the hundredths place. So that would be 90 hundredths. The last digit of 90 is 0, and it's in the hundredths place. And then finally, our last figure over here, we have 100 boxes. Of the 100, we have 1, 2, 3, 4, 5, 6, 7, 8, 9 boxes shaded. So that would be 9 hundredths. Make sure 9 falls in the hundredths place. And this is in fact 9. It's in the hundredths place. And those are our three decimal equivalents of the models. Now of the three models, we need to determine which models are equivalent. And the first two models are our equivalent decimals here. And so we find that they are equal. Okay, so now we have got to come up with a rule so that we don't have to draw decimal models every time we want to compare two decimals to determine if they are equivalent or not. So we ask ourselves, how can we tell that two decimals are equivalent without using decimal models? Well, it's actually very easy, but if you want some fancy words, if all non-zero digits hold the same place value, then the numbers are equivalent. Okay, so what on earth does that mean? Well, let's break this down. So it says if all non-zero digits, so that's going to be any digit that is not a 0. So here in the first number, 1 is not a 0, 4 is not a 0. So if 1 is in the ones place here, there should also be a 1 in the ones place in the second number. The other non-zero digit in this number is 4. It is in the tenths place. If you look at the second number, 4 is also in the tenths place here. So we have met those two qualifications. Now you might be asking, what about that 0? There's an extra 0 here. That is okay. You can have an infinite number of zeros to the right and it's still going to be equivalent as long as all of the non-zero digits 1 and 4 are in the same place values. Okay, so with that knowledge, because we have a 1 in the ones place here and a 1 in the ones place here, we have a 4 in the ones place here and a 4 in the ones place here, and then we have an additional 0, that's okay. This, yes, would be an example of equivalent decimals. All right, let's look at the second example. Now, initially you might think, oh, we've got 0s and 6s here, we got 0s and 6s here, we're good, those are equivalent. Take a second, take a step back, look at what's going on. Here, you have a 6 in the hundredths place. If you are careful, you'll notice that the 6 is in the tenths place here. They are not in the same place value. Therefore, they are not equivalent. So no, these are not equivalent. They are not equal to each other. The directions for these two problems read, write two decimal equivalents for the shaded region. In problem 1, you'll notice that this is divided into hundredths. Of the hundredths, we have 10, 20, 30, 40 of the blocks are shaded. So the initial decimal that you probably thought of was 40 hundredths, which would be written as 40 hundredths, 0 and 40 hundredths. Now we need to come up with a second decimal equivalent. Now there are an infinite number of answers to this. So use what you have learned from the previous examples. If you want to think of this in terms of tenths, then you would recognize that, hey, I have 1, 2, 3, 4 rows, each made up of 10 blocks. So if I were to just focus on the tenths divisions, so notice I've outlined them here. This is in 10 sections now. I have 4 of those 10 sections shaded. And so 4 of 10 would be 4 tenths. So that would be an equivalent decimal. Also, if you wanted to use that trick that we talked about earlier, you have a 4 in the tenths place here, you have a 4 in the tenths place here. You could put a 0 here, you could drop the 0 here, that's awesome. Or you could put, 5 zeros here if you wanted. You can have as many as you want as long as the 4 keeps its place value. It stays in the tenths place. Looking at the second problem, we have 10, 20, 30, 40, 50, 60, 70 out of 100 total divisions shaded. So we would express that decimal as 70 hundredths. For a decimal equivalent, we may choose to drop that 0 because we know 7 tenths would be equal to that number. We may choose to add a couple zeros, so you can put 700 thousandths if you wanted. All 3 of those numbers would be equal. Of course, the directions say write 2 decimal equivalents, so don't feel like you have to write several examples. 2 numbers is sufficient, but there are definitely an array of answers you could choose from. All right, name a decimal equivalent for each of the given decimal values. Again, there are lots of different answers you could choose from. Looking at this problem, we have 20 hundredths. You may choose to drop that 0, so that would give you 2 tenths. You may choose other answers like 200 thousandths. You may choose 2,000 ten thousandths, and so on. But this is a good answer for this particular problem. Try 2, 3, and 4, and I will fill in possible answers that you may have chosen. Okay, one possible decimal equivalent of 80 hundredths would be 8 tenths. You also could choose to add some zeros at the end, so you could have done 800 thousandths. You could have done 8,000 ten thousandths, and so on. There are literally an infinite number of answers you could have chosen. Popular answers for the next 2 problems. You may have added a 0 to make that 10 hundredths, or even 100 thousandths. In problem 4, 30 hundredths would be a popular answer. You may have chosen to do 300 thousandths, and so on. The answers continue. So in short, it doesn't matter how many zeros you have at the end of your numbers, as long as you are careful to ensure that the place value of the non-zeros remains the same. So you can have 0.75, and if you wanted to add 1 zero you could add 30 zeros if you wanted to. That would be an equal number. Just do not move the place value of the 7 in the tens place and the 5 in the hundredths place. And that's all for decimal equivalents.